All right, everybody, pardon me. Don't know why the auto didn't record the first time. Here is the 1.1 day 2 homework. All right, so like I said, and like we saw in class, if we need to rewrite our radicals, we know that the value outside the radical becomes our denominator, the value inside the radical becomes our numerator. Similar in this one with the 7th root of x to the 4th in the denominator. The only difference now is we have a negative for the exponent. And like we talked about with coefficients, the only thing that moves is our variable. From there, I go ahead and use my power rule. So 7 times 1, 7 minus 1 gets me my first term. Negative 4 times 7 eighths gets me my negative 28 eighths. If you want to reduce it this step, that's fine. 7 eighths minus 1 gets me negative 1 eighth. It can be a bit frustrating at first to work with things like 7 to the x. The derivative of 7 to the x simply is 7 to the x natural log of 7. It just basically fills in that spot. Negative x to the negative 4 sevenths, so negative 1 times negative 4 sevenths gets me 4 sevenths. Negative 4 sevenths minus 1 gets me negative 11 sevenths. And then 1/5 times negative 1, negative 1 minus 1. We are expected always to reduce fractions, so I went ahead and reduced that 28 eighths to 7 halves, and I've got my final answer. So again, something like 13. Again, I've rewritten my 6th root of x to the 7th. I've rewritten that cube root of x to the 5th coming out of my denominator. So it has a negative, pretty bad arrow. It has a negative for an exponent. And then again, the only thing that should be moving should be my variable, not my coefficients. So I take care of my power rule, 6 times 1, 6 minus 1. Negative 3 times 7, 6, 7, 6 minus 1. The derivative of 5 to the x simply is 5 to the x natural log of 5. Negative 1 times negative 5 thirds, negative 5 thirds minus 1. 1/2 times negative 1, negative 1 minus 2. And again, we always reduce fractions. If you took care of that in your first step, so basically you don't have this intermediate step, that is fine with me. Now, for equations of tangents, like we said, we're going to see the same thing over and over again. First thing we want to do is find that y-coordinate. Well, in this problem, we've been given the y-coordinate, so we actually have saved a step. So I find my derivative of x to the 4th. 2 times e to the x is its own derivative, so the derivative of 2 times e to the x is just 2e to the x. I substitute in my 0. Now, if you're not using as formula notation as I am, that's okay, but please have your derivative labeled up above. And so I know 4 times 0 is 0. 4 times 0 is 0. E to the 0 is just 1, so I end up with a slope of 2. And then I can write my equation. Y minus my y-coordinate equals my slope times x minus 0. Again, as I said, there's no reason that you have to rewrite it in slope-intercept form, so why bother? Pardon me. Now, in 16, they only gave me the x-coordinate, so I'm going to need to substitute in to find that original value. I found my derivative first using my power rule. I substituted into my original. I substituted into my derivative. By substituting into the original, I get my y value. By substituting into my derivative, I get my slope. And I can write my equation. Like we said in class, we can't leave it with the double negative, and my guess is a lot of people go straight to having the positive anyways. But I've got y minus my y-coordinate equals my slope times x minus my x-coordinate, or what ends up as y plus 22 equals 75 times x plus 2. 17, I've got to do just a little bit of rewriting so that I can find my derivative. And since I'm actually being asked to use this derivative to plug in 1, I'm going to have to take the time after I find my derivative to rewrite my equation. So I use my power rule. 5 times negative 2 minus 1 gets me my negative 10x to the negative 3rd. Negative 1 times 1/2, 1/2 minus 1. But now I've got to rewrite. So again, when I have a negative exponent, the only thing that moves is my variable. My variable moves to the denominator for the next piece, the x to the negative 1/2, but it also goes inside a radical. From there, I can substitute in to my original to get my y value. I can substitute into my derivative to get my slope, and then I can write my equation. Y minus my y-coordinate equals my slope times x minus my x-coordinate. If you wanted to leave that slope as a fraction, that's totally fine. 21 divided by 2, negative 21 divided by 2 is just fine as a slope. Now, for 18, they very conveniently have given us the y coordinate. So again, that's going to save us some time. I do need to rewrite as I find my derivative for square root of x. So for my derivative of 5 is 0, derivative of negative x cubed, negative 3x squared, and derivative of x to the 1/2 is 1/2 x to the negative 1/2. But again, because I'm going to plug in, I have to take the time to rewrite that 1/2 x to the negative 1/2 as 1 over 2 root x. Again, I was already given the y coordinate, so I'm just going to substitute into the derivative and come up with my value. And again, whether you want to work with the fraction, whether you want to work with the decimal, that's up to you. For writing the normal line, I think the fraction makes things a lot easier. We can't leave decimals in fractions. So by the time I went to my normal line, I focused on my fraction. And so, for my tangent line, I've got y minus my y coordinate equals my slope times x minus my x coordinate. And then for my normal line, I need the opposite reciprocal of my slope. So notice the y coordinate, the x coordinate haven't changed, but I take the reciprocal of 5/2, 2/5. I take the opposite of a negative number, positive, and I've got my equation for the normal line. Y minus 5 equals 2/5 times x minus 1. Now, 19 has a little bit more work than what we saw in class because it actually wants us to find the tangent lines. And again, like we talked about in class, if we have horizontal tangents, we know the slope is 0. So, first things first, I found my derivative. Notice I set my derivative equal to 0, and I factored out 6 to make my factoring a lot easier. From there, I know that the factors of negative 2 that add up to positive 1, and now I've got my x values. Since it actually asks for the equation of the tangent, I've got more work to do. I need to plug negative 2 into the original so that I can get my y value. We already knew the slope was 0 because it told us it had a horizontal tangent, and so I'm able to write y minus my y coordinate, y minus 3, equals 0 times x plus 2. If you just write this as y equals 3, since what's on the right-hand side would cancel out, that's fine. But again, since it doesn't say what form of the line to write it in, any form is acceptable. And then finally, I need to substitute 1 in to my original function to get my y value. And now I'm able to set up my equation. Y minus my y coordinate equals 0 times x minus my x coordinate. Notice again, I took care of the double negative. That's at the very least what we need to do. But you could have even gone so far as to just write it as y equals negative 6. All right, hope that helps. Sorry about the audio issue on the first video, and I'll see you soon.